Hello. All right. So, 3 over 4 times 8 over 5. 3 over 4 times 8 over 5. So we're going to multiply the top and we're going to multiply the bottom. So the top is 3 times 8. The bottom is 4 times 5. So 3 times 8 is 24. 4 times 5 is 20. So at this point, we have to reduce our expression. So the first thing I'm going to try and do here is I can see common factors between 24 and 20. So I'm going to try and reduce. Now, the greatest common factor I can see here is 4. So I'm going to say, well, how many times does 4 go into 24? It's 6 times. And how many times does 4 go into 20? It is 5 times. So at this point, I'm going to, no, this is called an improper fraction. And, I did not talk about that one earlier on. But for an improper fraction, the top number has to be bigger than the bottom number. And so here, 6 is bigger than 5. So we want to change this to a mixed number. So we say, how many times does 5 go into 6? It is 1 time. So it is 1. So 5 times 1, you have to multiply them, it is 5. So 6 take away that 5 is 1. So your top number is going to be 1 and your bottom number remains as 5. So very quickly, let's just go through that again. 5 goes into 6 1 time. We write that down, 1. And so 5 times that 1 is 5. You take that 5 away from the 6, you get 1 left. Then your remainder 1 is going to go on top of your fraction and then divided by your denominator. So your denominator will not change in either case. Now I want to quickly show the second method. So I'm going to do method 1 here, and I'm going to do method 2 here. So you may see me use method 2 a lot, just because I find it shorter and easier to work through. But feel free to use method 1 as well. So 3 over 4 times 8 over 5. So for this particular method, so you are allowed to cross out and reduce numbers either vertically or diagonally. So you're not allowed to cross out numbers horizontally, for example, 4 and 5 together or 3 and 8 together. No. You're only allowed to cross out numbers if it works between 8 and 5 and 3 and 4, or between 3 and 5, that's diagonally, or 4 and 8. So you can either do vertical or diagonally. So now, over here, I want to try and see if I can cancel anything out in any of these directions. Well, looking at 3 and 5, there is nothing we can do there because there is no common factor. Now looking at 8 and 5, there's nothing we can do. 3 and 4, there's nothing we can do. The only way we can do something here is to do 4 and 8 together. Now between 4 and 8, I'm searching for the greatest common factor. The greatest common factor is the factor that is the biggest number that goes into both numbers. In this case, it is 4. Now 2 works. 2 is just a factor. 2 is not a greatest common factor for this particular question. So 4 is better because then I only need to do it once, and that's it. So I'm going to say, well, how many times does 4 go into 4? It's only once. I cancel it out. I write 1. How many times does 4 go into 8? Twice, because 4 times 2 is 8. So I cancel it and I write 2. Now there is nothing else I can do here. So therefore I have to revert back to what we did here, which is write out and multiply the top write out and multiply the bottom. So the top is 3 times 2, the bottom is 1 times 5. I just multiply, so 3 times 2 is 6, 1 times 5 is 5, and I just have to complete it like here. So 6 over 5 gives you one whole number, 1 over 5. So this is how this one is done. So right away, let's move on to the second example. So I'm going to call this example 1 here. And let's move on to example 2. So we've seen how to work through regular fractions here. So what if we've been given two mixed numbers? What do we do? Well, let's see. One whole number, 7 over 8, times two whole number, 2 over 3. When given two mixed numbers, or even just one mixed number, what you need to do is, first of all, convert the mixed numbers into fractions. So mixed numbers usually is going to go to improper fraction. So the way we do that is, in this case, we multiply the bottom and the whole number, and then add 7 to the result, and then divide it by 8. So your denominator never changes. So I do 8 times 1 is 8. 8 plus 7 is 15. My denominator is not changing. 3 times 2 is 6. 6 plus 2 is 8. That is 3 times 2 is 6. 6 plus this 2 is 8. 8 over 3. Like that. Now over here I can see that I can cancel these two out together. 8 goes into 8 once and into 8 once. And I can cancel these two out together. 3 is the greatest common factor. 3 goes into 3 once, and 3 goes into 15 5 times. So the top is going to be 5 times 1, which is 5. The bottom is 1 times 1, which is 1. So it's going to be 5 over 1. And of course in math, this is 5. Alright, so for example 3, we're going to be doing a combination of mixed number and whole number. So when we're talking about a whole number, there's no fraction there. So it's just the whole number. So for example, the number 5 is a whole number. The number 10 is a whole number. So numbers or integers without fractions are whole numbers. So example 3, let's do, no, 3 whole number times a mixed number. So 3 whole number times a mixed number. The mixed number here is 2 whole number, 1 over 4. So the first thing we need to do here is we have to convert the mixed number into an improper fraction. And then whenever you have a whole number, it's the same thing as that whole number divided by 1. Because we want to convert the two of them into fractions, and then we can just multiply them out. So like we're saying, usually when you have a whole number, it's the same thing as that whole number divided by 1. Remember, our goal is to convert each of these two into fractions before we multiply them. So 3 turns into 3 over 1. And so 2 whole number, 1 over 4. So we convert now. So 2 times 4 is 8. 8 plus 1 is 9. So it's going to be 9 over 4. Now over here there is nothing that can cancel out. It doesn't work. So I have to multiply everything out by doing the top. So 3 times 9 is 27. And 1 times 4 is 4. And so we have to convert this to a mixed number now by saying, how many times does 4 go into 27? Well, 4 times 6 is 24. Yeah, so it is 6 times. So 24. So we take 24 away from 27. We get 3. So it is 6 whole number, 3 over 4. So right now, we're going to move on to division. Alright, so division of fractions, whole numbers, and mixed numbers. Now this one is very similar to when we did multiplication of all these items. The only difference is when you're writing these divided by these, that second entity, you have to make sure you reciprocate it, or make the top bottom and make the bottom top, and then you change your divide sign to your multiply sign. And then you do exactly the same thing you did when you were doing multiplication of all these items. So let's try an example here. Example 1, so 5 divided by 2 over 3. So 5 divided by 2 over 3. So for a question like this, so you have to turn 5 into a fraction by saying 5 is the same as 5 over 1, and then you already have 2 over 3. So we change that divide sign into the multiply sign, and we flip the 2 over 3 to get 3 over 2. And then we repeat what we did earlier on. So 5 turns into 5 over 1. The divide sign turns into the multiply sign. 2 over 3 turns into 3 over 2. So at this point, I can't cancel anything out. So I'm going to do 5 times 3 is 15. And 1 times 2 is 2. Like so. And then, so here, I'm going to convert this into a mixed number. So how many times does 2 go into 15? It is 7 times, because 2 times 7 is 14. So I take out 14 from 15, I get 1. So I have 1 over 2. Like so. Example 2. So the question says that 5 over 8 divided by 2. So again, I'm going to convert this 2 to a fraction by saying 2 is 2 over 1. And I'm going to change this sign to the multiply sign and then multiply. So I'm going to have 5 over 8 times 2 over, no sorry. So first of all, let me just focus on converting. Let me just focus on converting the 2 into a fraction. So I'm still having 5 over 8 divided by 2 over 1. So now, 5 over 8, I'm going to flip the 2 and the 1, and I'm going to change this sign to the multiply sign. So times 1 over 2. So at this point, I'm going to multiply 5 and 1 to get 5, and I'm going to multiply 8 and 2 to get 16. And that's it. So we can't reduce anymore here. There is nothing else we can do. So we just leave it as is. Let's move on to another example. So 9 over 10 divided by 5 over 3. Nine over 10 divided by 5 over 3. So for this one, so equals 9 over 10. I change the sign to multiply. I flip the 5 over 3. So I get 3 over 5. So there is nothing we can cancel out here. So we can't reduce. So we multiply everything out. 9 times 3 is 27. 10 times 5 is 50. Also, there is nothing else we can do here. So we just leave that as is. Example 4. So at this point, let's try a question that is dealing with mixed numbers. So 6 1 over 8 divided by 2 3 over 4. So 6 1 over 8 divided by 2 3 over 4. The first thing we want to do here is convert each mixed number into an improper fraction, and so at this point we're going to change the divide sign to multiply, and then we're going to flip the second term. So 6 times 8, 48 plus 1 is 49 over 8. Divided by 2 times 4 is 8 plus 3 is 11 over 4 equals 49 over 8. I'm changing this divide sign to multiply, and I'm flipping this to get 4 over 11. At this point, I can do something about the 4 and the 8. There's a greatest common factor there. I can't do anything between these two. 11 and 49. Now 4 goes into 4 once, and 4 goes into 8 twice. So I do 49 times 1 is 49, and I do 2 times 11 is 22. But now I have to convert this to a mixed number. So 22 goes into 49 twice, because 22 times 2 is 44. So I'm going to have 244. So I'm going to remove 44 from 49. I'm going to have 5 left. So 5 over 22. Alright, so right now we are moving on to the last part of this lesson. So we have one more thing to discuss. So solving problems with fractions and order of operations with fractions. So the first one we're going to talk about here is a word problem. So of course, word problems are basically problems in words. So problems in words and sentences and statements. So example 1. Agnes scored 5 goals in Manitoba Stakes tournament. This was 1/8 of her team's goals. How many goals did Agnes's team score altogether? I want to do this example with us in 2 different ways. So I'm going to say method A. And if this method doesn't make sense, don't worry. I think the second method will make sense. So we have to take the 5 goals divided by 1 over 8. So 5 divided by 1 over 8. So 5 goals for Agnes out of her team's total number of goals. And the 5 goals represent only 1/8 of our team's total goals. So here we're going to do, we're going to change 5 to 5 over 1. They're the same. So divided by 1 over 8 equals 5 over 1 times, you have to flip when you change the sign to multiply, and equals 40 goals. So that means Agnes scored 5 goals out of the total of 40 goals for the team. I want to look at a second way of doing this. Now 1/8 of a whole. So let's say the whole is 1. So 1/8 means there are 8 different portions to the one whole. So for example, seven and 8. So each portion here. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 different ones here. So the entire thing represents a whole, and so each one is 1/8 of a whole, basically. So Agnes scored 1/8. So that means Agnes scored 5 goals. So 5 goals here. I'm going to say Agnes here. So Agnes has one box, the first one, scoring 5 goals for that. So we have 8 different spots. So that means if you want to break it down like this, because Agnes's 5 goals represents 1/8 of the whole. So that means there are 8 different spots, let's say. So that will be 5 plus 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 5 equals 40 goals in total. Now let's move on to the last example here. All right. So the question is 3 over 4 minus 2 over 3 divided by 4 over 5 times all right, so 3 over 4 minus 2 over 3 divided by 4 over 5 times 1 over 8 plus 1 over 4. So this one has to do with order of operations. So usually anytime you have like just different operations all together, you're multiplying, you're dividing, you have brackets, like just various operations all together, then so those ones are order of operation questions. So you have to go with what we talked about previously, called BEDMAS. So BEDMAS, so BEDMAS, like that. So this tells you what to do first before another. So if you see anything in bracket first, you have to do it first. Next is exponent, division next, multiplication. Division and multiplication are together, if you will. And then addition and subtraction are together, and then the last ones. So let's try and see. So right away, I can see bracket here. So we're going to take care of that first. So I'm going to write the rest here. So 3 over 4 without doing anything about that for now. And then times. So I'm going to do this all together here. So here, I want to have the same denominator. So I'm going to do times 2 and times 2 here. So I'm going to have 1 over 8 plus 2 over 8. So 1 over 8 plus 2 over 8. So that's 3 over 8. So again, 1 times 2 is 2. 4 times 2 is 8. I have common denominators, so 1 plus 2 is 3 over 8, like this. So the next thing we want to do here, is this. The next item is division that we have here. So we're going to do this division here. So in order for us to do this division, I'm going to do 2 over 3 times 5 over 4. So 3 over 4, so 2 over 3 times 5 over 4. So 3 over 4 minus. So I'm doing 2 over 3 times 5 over 4, and then times 3 over 8. So I want to multiply these two right now. So equals 3 over 4. When I multiply these, I'm gonna get actually I wanna cancel this out. So this is 1, this is 2. So that's 5 over 6. So minus 5 over 6. 5 over 6 times 3 over 8. So minus 5 over 6 times 3 over 8. So again, we have to multiply this. So equals 3 over 4 minus. So when we multiply this, we're going to have, so I can cancel this out. So 3 here, 1, 3 here, 2. So I'm having 5 over 16. And all we have to do here is subtraction. So I want to have the same denominator. So I want to multiply this by 4 so that we have 4 and 4. So times 4 times 4. So I'm going to have 12 over 16 minus 5 over 16. So this is 12 minus 5, which is 7. So this is 7 over 16. So let's just quickly go through this here. So we go with BEDMAS because we have a bunch of different operations. We have to do bracket first. So we deal with this first. We add. When we add this, we get 3 over 8. So we write these 3 items down like that, times 3 over 8. The next one is division. So we're working through this. So we want to evaluate this. We do times, we flip 5 over 4 times 5 over 4. We write 3 over 4 minus 2 over 3 times 5 over 4 times 3 over 8. So we cancel stuff out here. So we're going to have 3 over 4 minus 5 over 6 times the last one, 3 over 8. So here now we can cancel this out. So we get 3 over 4 minus 5 over 16. We want to have the same denominator. So we multiply each by 4 here. And 12 minus 5 is 7. So 7 over 16. So this brings us to the end here. Thank you.